Hi everyone, and welcome to our video on finding the area of a triangle given it a side angle and a side. So currently we have a triangle marked with all of the angles and letters and a height. So the height makes a right angle. Usually our easiest equation for a triangle is 1/2 base times height. Okay, so on this problem, let's use A as the base. Let's show where we get a new formula from, and then h would be the height. So we would have a equals 1/2 a times h. All right, however, let's say we don't know what the actual height is. So a side angle side problem means I have the side A and the side B, and then this angle in between. Okay, well, let's use this angle in between with SOHCAHTOA. So that angle in between that's useful with SOHCAHTOA is I do have an opposite side, and I'm focused on this right triangle. So SOHCAHTOA can only be used on right triangles. So I'm bolding this right triangle out. And I have, so notice all of A is this whole length. So A is not useful for it. So the adjacent side we wouldn't know. So cosine's no good. Okay, same with tangent. Tangent's no good. So it looks like sine is what we would want to use on this. So sine of that angle C would equal h over b. Okay, well, let's solve for h in this by just multiplying both sides by, let's write that down, by b. Oops, let me change my color. So if I multiply both sides by b, those would cancel, and we would see, oh, h is b sine of c. Now that we have h by itself, let's use it to substitute in to our original area formula. So 1/2 a, and then h is b sine of c. And then I don't need those parentheses, I was just using them to show how it got substituted in. But there's our area formula. Okay, so that's the area of a triangle with a side angle side. So the just like it is here. So we have that, and then the angle in between. Okay, so that's how it works. And these letters are arbitrary. You can change them. So the way I think of it, so there's others. So you could do AC and then sine of B. So just kind of rearrangement of the letters. So the two sides are different than the angle. Okay, so the angle letter, and then one other, 1/2 BC sine A. Something like that. Okay, so, and they might also do one other formula. Okay, so careful, because the angle, so angle A is tricky because I used A for area. So maybe let's put the whole word in, area, because capital A is also an angle. So that can be a little confusing. So one other way that they write this, again, they might just do capital A for area, but let's write the whole thing. They might do 1/2 AB sine theta. Okay, where they just say, well, that angle theta is between two known sides. Okay, so that's the other formula. So they're all the same. They're all the same formula, just with rearrangements of the letters. Okay, so that last formula might be the best, though. Just think, oh, if I have the angle in between two known sides, I would have this. All right, so let's see this get used. And they instantly just make it more interesting than just a single triangle. They throw in a circle, too. So it says, find the area of the shaded region where, and then that's it. Write the answer as an exact value. I think that's all we'll do. The approximation we would just type into a calculator. Okay, so this is a circle, which means from here to here is the radius, which means this is also the radius. So that must also be 11. So it looks like we have a triangle. So I'm going to break this apart and say, well, I have a triangle all by itself. That's pi thirds. It's poorly drawn, but there it is, pi thirds, and then 11 and 11. So that means I could find this area. Now, I did forget to mention in this formula, the angle can be radians or degrees. It doesn't matter. Okay, so they gave us radians in this problem. Okay, so let's find the area of this triangle. So that would be 1/2. So I have two sides that are known. So 11 times 11, and then times sine of the angle in between. Just like that. That's it. That's the big setup. Now, sine of pi thirds we can do. That's close to the y-axis in quadrant 1, so it is radical 3/2. So the area of the triangle part is 1/2 times 11 times 11 times square root of 3/2. Okay, so sine of pi thirds we could do, so we did it. And then we would just say, well, 11 and 11 times 1 is 121 times square root of 3 is square root of 3. In the denominator, 2 times 2 is 4. Okay, so I'm going to cloud that. That's the area of that little triangle. The other thing I need to do, so I'm going to say, well, this, let's number it. So there's number 1. Number 2 is this area. Let me do it in a different color. It's the leftover shaded area is what I want. Right there. Okay, so that's the other area that I want, because if I have that, then the total area is to add area 1 and area 2 together. Okay, so for number 2, so this is a circle. Ooh, let me try that one more time. Let me do it from, there's the center. Okay, so we want this shaded area again. I'll not shade the whole thing to make sure I've got enough space. But I want this angle. Okay, so I know all the way around would have been 2 pi. So I should subtract then pi thirds from it. We would need to get a common denominator. 6 pi thirds minus pi thirds is 5 pi thirds. Okay, so we need this angle. 5 pi thirds. We'll circle it on both so we can see it. Okay, so we need that angle because now we're looking at the area of a sector of a circle. Okay, so and if you don't remember the formula, that's not too big of a deal because we could figure it out. So we know that the full area would have been pi r squared. Now we compared this pi right here, so notice that's halfway around a circle. Halfway around a circle. So it's saying we should have taken half of fully around the circle. So this is the half of the angle that's, oops, pushed a button. That's half the angle that's needed. Okay, so we're going to say, well, a generic formula for our area of a sector of a circle should be 1/2 theta r squared. Okay, because if I go all the way around, so just to check, if theta equals 2 pi, which is fully around the circle, notice the 2's would cancel and it matches that formula. Okay, so it's just manipulating the angle to figure out what I should plug in. Okay, so the area of the sector of the circle is 1/2 theta r squared, where theta in this problem is the 5 pi thirds. So we have 1/2 5 pi thirds. We still have the same radius as before. It's still 11, still getting squared. And then now we just need to do our order of operations on this. Okay, so 11 squared is 121. It will times 5. So I'm just doing my scratch work. 1 times 5 is 5, and then 10, so 605. Okay, so we have 605 pi in the numerator, and then 2 times 3 in the denominator is 6. Okay, so that's the area of the sector of the circle. And so for our final area, the area that they wanted in the shaded region, is to add our two areas together. So 121 square root of 3/4 plus 605 pi over 6. Okay, and then I'm gonna stop that there. We could get our decimal approximation if we just enter that in. They might want us to combine these. I don't think they would care that much. I think mostly they would want the decimal. Okay, so if we need to plug that into a calculator, we could. But that is the breakdown. Okay, so the new thing was the triangle. Okay, so if you have two sides and then the angle squeezed between, we can always find that area. All right, that's that. If you have questions, please let me know. Otherwise, thanks for watching.